Hey, welcome back. So, as you can see, the machine is back in running condition again. And in this video, I'll go over what has changed and all that since the last video. Let me open up this door so we can have a better look. So, door still is the same way. These things here, a week ago, I think it was that one, I smacked my head in there really good. I really hate this design. I might even just cut these things out and just have it flat, because it is so. I've hit my head into this thing so many times. So previously I was working on getting the gantry nice and straight, the surfaces where the planes go, and my plan was to use one of my levels. I have a 5 and a 7-inch level, and I was going to use the laser plus combination with the webcam sensor and measure all that, check their straightness, and then transfer using like an epoxy replication method to get those surfaces, the top and the bottom of the X rails right there, and get those very flat. Turns out that the gantry is, like, the raw steel tubes are straighter than those carpenter levels by quite a bit. So I ended up just using the machine as it is. So and also, like, I thought about the effort involved, and if I go to the effort of straightening all of that, then I might as well do the y-axis as well, because there's no point in having one without the other two. So I left it for another time because I really wanted to get the machine back and up and running. And what I'll probably do at a later time is go in and do all three surfaces, so the Y rails and then the X top and bottom. I have since taken out the spoilboard, and I have this I think it's a Viver 6-inch vise, and I have it just kind of temporarily on there. It's certainly not the greatest fasten. It's not fastened down very well. I'm just reusing the bolts that the spoilboard, the MDF spoilboard, was using, and it seems to be holding, at least for aluminum, the stuff that I'm doing. With the machine running, I've noticed the extra weight of the gantry risers, as they're now, well, they're considerably different than the way they were. The extra weight with the grout and also the double steeled walled gantry tube, all that extra weight certainly has changed how the machine performs, especially like moving it around. It's definitely now like the machine is top heavy. These servos certainly don't care about the extra weight. The extra weight of the gantry has made the whole machine very top heavy, and when it's moving around now, like, let's see if I can get this to, you can see now the base of the table here, this is now starting to move now. So I probably need to get some counter balance. You can definitely see over here when I move this around here. And this is just jogging around at 1500 millimeters a minute, so not very fast at all, not like G0 rapids. The BK and BF blocks, I have some spacers that I originally 3D printed out, and you can tell even here, like the servo here for both y-axes, like it's being held on by a 3D printed part, and so far they have held up, but the spacers here, these are for the BK and BF blocks, these things have been getting crushed, and this one's the BK block. It's not so bad, but the one over here is, like, certainly it's pretty gone. So I've been making some aluminum ones. So the first things on the machine I've made so far is some new spacers that'll keep this whole setup more rigid. I think what's happening is the machine, as it's especially on Y, as it's moving, it's putting so much load on the BK block, because this side here is where that's taking the brunt of that motion, and I have a feeling that it's slipping back and forth on the 3D printed parts, especially when I'm using one of the insert tools. So this should definitely alleviate that, and I have them on the BF block over here as well, but that's less important. This way at least I can tighten things down properly without them worrying about coming loose on me. For end stops on the Y, temporarily I'm just using these guys, and this is just touching the steel here. And I don't know, I might leave them like this. I'll have to see. So far they work pretty good. And also, like, if I were to crash into this, I'll probably crush this blue cap because I've done that prior. But the 3D printed mount will probably pop apart, and the sensor will probably be able to still be used. I haven't decided what to do about the vise. Right now it only gives me about 3 inches of clearance for the Z assembly. If I move this over, so not a whole lot of clearance there. One of the options I have was, and also it's not very stable the way it is. The 2 tubes here, there's one there and then there's one there. That's part of the base of the frame of the table. What I was thinking of doing is getting 2 more steel tubes and then welding them onto this raw steel on both sides, and then I can rotate this vise 90 degrees and then drop it in, and then I would have another 2 inches of height, so I would have 5 inches up here. Likely, I think it would probably make sense to take some of these bolts, like, M12 or so. I don't know how big these things are, and I know this is like totally jank, but it's working so far. But what I'll probably do, if I were to go with this whole method, is to weld some of these like M12 bolts and use the CNC machine, because I can get the spindle quite low, and I can probably face off the tops of those bolts and then have like a very solid location where I can bolt the vise to, and it'll be like recessed quite a bit. And what's nice about that is this whole thing would be much more rigid, but it does give me the freedom to then in the future put a fixture plate down and not have to worry about any of the assembly of the vise holding it, getting in the way. Preferably I'd have a fixture table, and then I'd have like mod vices, and I think that's probably the best way I would do it. But it is very convenient to have like a big giant vise like this that I can just clamp things in and go to town on it. Trimming this vise in, I only had to move this corner up a little bit, and I'm just using some like pop cans just to shim it up. I think a pop can is like 100 microns. I do like the orientation of the vise like this, but like just how it clamps and stuff. One thing I don't like is like when I'm putting in some parallels, I can't see if there's any chips in there, because the whole table and the vise is in there, but the whole table is also quite lifted. So like I can't lean over and look and see in there. So I've been just relying on air blasting and wiping it in, but doing all that is kind of tedious. And maybe if I rotate this whole thing, then I can look directly down the vise jaws and see if there's any debris in there that's going to get in the way of some whatever I'm clamping. Since the motor mounts on the Y axis is holding up pretty good, I'll probably continue and get the BK and BF blocks, get some solid aluminum spacers for those. So like that one, like this one it's the original 3D printed one. Then I had to chop it up because the gantry risers, they kind of protrude outwards. And then there's like some spacers in the top of there just to get everything lined up. Replacing that would be kind of a priority right now. Same deal with this one, like it's epoxied and chopped off to hell, and there's spacers and stuff. It's desperate for some new aluminum parts. You can see there, this is just hitting the aluminum there. I was thinking about integrating the servo mount for the x-axes and the BK block spacers into one unit, but I think what I'll do instead is just keep them separate. That way it's a simpler task to deal with. Once I get the alignment of the BK blocks or the ball screw in, then getting the servo alignment, I can just kind of focus on that. And so for milling these parts, like this one here, this is a spacer for the servo BK block for the ball screw. I've been trying my luck with some insert tooling, so I've been using this one here, and this one looks like I can index it 4 times, and so far it's working pretty good. At least I'm running it in aluminum. It does smear, like when it's going and when it's cutting this last part here, it tends to want to smear the edge over. And what I'm finding is this thing, like it likes to go fast. I'm running it at 5,000 millimeters a minute and 24,000 RPM, and I've taken up to 1 millimeter. I think this diameter is 8 millimeters, this insert. Don't know off the top of my head. It might be the whole diameter of the tooling. But yeah, so far it's working pretty good. The edge is held up pretty good. There's a bit of some aluminum chip welding on there, but like it's really easy to take off. And these inserts are really cheap. Originally on the machine, there was no way I could run this because on the original machine you have a small section of tube which is called, I believe it's called the rollers, and the ball screw runs through it, and that doesn't really give you a lot of material to be rigid, plus it doesn't give you that great of a mounting surface onto the gantry. You rely on 4 bolts that, you know, the surface area of those 4 bolts is not a lot, and at least I found on that design, like it was flexing quite a lot. But with this whole setup, it's much more rigid. I had an indicator, I'll throw it again on here, but I was getting about 3 thou of deflection that I could put on the, like by just torquing on the spindle, you know, and putting dial indicator roughly where the tool would be, and yeah, like I could just get it to flex probably as much as these dual gantry carriages will flex or move. Like these don't have any tension on them, any preload, so like there's always going to be a bit of play in there. Originally I was running just singles, but here now you have a bigger footprint and much more rigid that way. So far this is working really good in aluminum, and I will check it in steel as well. Something I've noticed with this tool is when it's going, I'm getting much better performance when it's conventional cutting, so versus climb cutting. And in Linux CNC, like at least so far, I haven't run any like full G-code programs. I'm doing a lot of stuff just manually right now, just getting used to the device and everything. And in Linux CNC, they have at least in UI that I'm using, which is Qt Dragon HD. So it has some little helper tools to generate G-code. So one of them is just like a facing operation, but it does a zigzagging of climb and conventional cutting. And what I think I'm going to do, because I like running these so much for just like manual work, is see if I can extend that script that it's using. It's probably Python based, and see if I can just put in a parameter to specify doing just either climb cutting or conventional cutting, where like, you know, it'll run and then it'll lift, you know, and then do a G0 back to the next stroke, and then just keep on, you know, cutting it that way instead of zigzagging back and forth. And I think that should perform a lot better for these style end mills. Let me know if you have any tips for using these round insert ones. I know they take a considerable amount of force to keep them engaged, and what it's probably trying to do while it's conventional cutting is keeping it fully engaged in the workpiece a lot more than if you're conventional cutting. For comparison, here on the left here is a single flute end mill doing climbing conventional cutting back and forth, and that's what the result looks like. This is like the spindle's trimmed in really exact right now, so it's like there's nothing there. This is the round insert one, and if I can get them both side by side, that's how they look comparison wise. I'm finding that it's hard to tell on this. This is doing in both directions. One direction it does a lot better. The other direction tends to want to smear it, and I don't know, it loses engagement in the workpiece. Getting the gantry squared didn't end up being too much of a problem. What I did was I had all the bolts on both sides loose and did my squaring method I've shown in a previous video. Getting the Z assembly rotated over, so getting it rotated this way, that was quite a challenge. And what I ended up doing was getting a chunk of wood and pinching it between the gantry, so I'm moving it over and doing getting it stuck in there against the riser here and the Z assembly, and then pinching it, and then that was enough to push and rotate this over enough so I could get it like rotated to one side so I could tap it into place. And but yeah, I was worried that the bolts on the steel back plates were too small, and I wouldn't be able to have enough freedom to rotate it, but it was enough to get everything squared in. Something else I noticed when I was getting the Z assembly trammed in was, like, as I tapped this thing, like I had all the servos running, the frequency that things start oscillating is now different because of the gantry now. And I'll show you what happened. Let me get my e-stop ready because it's going to be loud. And I was just tapping on this, and if I tap a little harder, so you can see, let me turn it back on. So I get a bit of resonance happening. So I have to go back in and tune the servos. I believe what is most likely is one of the Y servos, but it shakes the hell out of the whole machine, and I think what's happening is the gantry is moving on probably one or both of these Y servos and resonating that way. So I'll have to go in and fix all that because that's totally not cool. The only servo that has any damping is this one here. This one up here is the one we hear. So if I move this, so yeah, I'm not running this machine right now at its fullest capabilities because it'll probably tear parts of it apart, the plastic mounts and stuff. I've dropped the acceleration by half. Things are not moving too fast. And yeah, I have a feeling like if I were to do the like a 0 when the machine is over here in that corner and then ramped it to home, it probably would tear one of the servos off. So until all those parts are replaced, those plastic parts with aluminum parts, I'll have to go easy on the setup. With the spoilboard out of the machine now, there's really not much of in there that's not waterproof, so I could start playing around with some flood coolant. This corner here, the stainless steel chip pan, everything is flowing to this corner, so I will have to build something in here, a collector and other odds and ends to get that running. Even though the ball screw is out of the way now, I'm still getting obviously chips and stuff on the rails, I want to cover this up somehow, and I've been thinking about putting some stainless steel. So if I take this piece here, so this wouldn't be, this is just an offcut. What I would likely do is get a piece here, cut in, so these tubes will go down, and then I would bolt this piece to the rails here, and then that would give me a nice nice wall that is like impervious, and have it just underneath where it is right now of the X rail, and yeah, that would cover a lot of stuff on that side. And I've been playing around with ideas of like movable covers and stuff, and I might look at that, especially on the gantry. Like, unfortunately, the gantry, like, it moves quite a lot, but there's not a lot of space. For instance, on this side here, I move this over. So when everything's squished in, there's not a lot. Like, what I could do is put a cover that goes over top of the risers here, and then I can, then I have like 6 or 8 inches to work with, and then I could like have some stainless steel covers that would, overlay on top of each other, and there'd be enough space. The other side, same deal. The only difference is I would have to deal with this loop here, so I might not have the same amount of space. So there's, I don't know, I might look at also like I think it's polypropylene, getting some fabric based ones put in there, but like I would like to have something that will cover the ball screw and the rails from getting all the nasty chips in there. Taking this whole thing apart to clean it frequently is kind of a nuisance, and the more I run the machine, the more issues I'm going to have with filling chips in on all the bearings. So I have a piece of pine over there in that corner, and when I put the machine, if I tell it to go home, so when I'm doing a tool change, if I drop an end mill 2 feet or so, it's probably going to stick into this soft piece of pine and not knock the tip off of it. I might have something in here, not wood, but maybe a rubberized thing, just to work with tools and stuff like that. So I'll end it here. This was, that's the status of this machine, how it is currently. It's great to have the whole thing running again. Putting it together was a real pain just because of my back issues right now, and like filling all this stuff with grout is, made it everything a lot more difficult to move around. Unfortunately, all that effort with the laser level and webcam, I ended up not using any of that stuff for this, but like it gave me a tool, like a nice tool that I can use to measure things really well. Now that I have the working machine, I'll probably make a nicer setup with those tools, some machined parts and stuff. And in the future, I'll revisit this and get the surfaces for all the rails probably scraped or epoxy leveled, and but that would involve a complete teardown. So let me know what you guys think about this, and I will see you in the next video.